Before I start the lecture today, there is also, we have already discussed about the project. Today, early morning, I have already uploaded the project guideline, and I distributed you to different groups. I told you I will do it randomly. So each one of you now can access the Blackboard and can see in which group he or she is, or they are. And you also can see the project guidelines there. So let me check. The project guidelines here. Let me share it with you so we can discuss it quickly before we start the lecture. I'll share my screen. So this is a project guideline that I published today. So I said the project will be done by a group of students. Each group should choose one real-life application. I didn't put examples or list. I keep it for you to make it more simple. So you can choose any real-life application that you believe that it needs a database, like ticketing system, university registration system, a clinic management system, any project. Examples that are done in class are not allowed to be used unless they are implemented a completely different way. The chosen database should be at least 4 to 5 entities with relationships, different kinds of relationships, and real-life attributes. So I said minimum 4 to 5 entities. You can do it more. It's up to you. Each project contains a list of DDL and DML queries. So you know about DDL query so far. So after you create a project in the PHP-MyAdmin, you should have created different DDL queries. And you should keep this DDL query because you are going to put a copy of this in your report. Plus DML query that we will start talking about it. So I think so within 2 weeks we should finish the DML queries. So in the meantime, you can finish the design part, the ER diagram, the relation schema, the DDL query. And whenever we have a more progress, then you can go to the DML part. So queries should be executing using PHP-MyAdmin, as we did before in DDL, or which is, I will give bonus if you do it, a user input interface, like creating an interface using any programming languages, where the user can insert data using this interface directly in the database. It is highly recommended. You will get a bonus. So it is highly recommended. It is not required, but highly recommended to create a user interface using any higher level of programming language like Java, Python. A user should have the ability to choose, delete, update, or insert using buttons and text feed using this interface. This is a very important part. You should present your project during the last lecture, which will be December 5th. The project presentation should be done by the whole team. Each team should manage the presentation internally. So it's up to you how you present it. As I told you, I can ask any question for any one of you. So it doesn't mean you should. So all the group members should be aware about the whole project. I will not accept during the presentation. Some of the members will tell me, okay, this is a part I didn't do it. But being in this project, you should be aware about it. The deadline to submit a project deliverable, because I need 2 days at least, is December 3rd. And what the project deliverable that should include a Word document that contain an ER diagram, relational schema, DDL query, and DML queries, and the source code for the graphical interface if exist. So, any questions, guys, before we start lecture concerning the project? Anyone has any question? Is it clear? Ivan, go ahead.
Yes. Hello, good morning.
Hi, good morning.
Um, I guess I'm just wondering, when you say choose one real life application that needs a database, wouldn't an application in real life that needs a database already have a database? I'm a little confused by like that part, choosing a
No,
real
which
life
means
app.
that which means that if you should choose a real life project that need a database. For example, if you are dealing with an application that there is no data to be saved, so this application doesn't need a database. You can't choose it as a subject for your project. Let's give an example. You're creating a game, no database, except if you are going to save the user's scores. But if you see that this game has no database or no data to be saved, so in this case, you can't choose it here as a project. So the aim from this is to choose a subject for your project that need a database in order that you can create a database. Is it clear, Ivan?
So it has to be something that exists already?
No, it doesn't have to be something that exists, but it's better to be a real life application, which means that it can be already exist. And I think so most of them will be exist. You will not get something extremely new. I'm okay with this, but it should be your own work. So as I give you an example, like clinic management system, you have a clinic, you need a management system for the patients, the doctors, the patient record, and university registration system, ticketing system, booking system, all can be an example for this.
Okay, thank you.
Good luck. Paramveer.
Yes, so we can use PHP for user interface.
Yes,
All right.
yes. Any
Okay.
programming language. So Java, Python is just an example. Any programming language you can use. I said it is highly recommended to use higher level programming language. It is not required, but highly recommended, and you get a bonus for this. Any more questions concerning the project? Callum.
Hey, so for the programming interface, it just has to be for the database, right? Like you don't actually have to make an application for a
No,
database, right?
yeah, just an interface. For example, let's take an example. You are creating a project for a clinic, and you want to write a query for creating a new patient. So you should have an interface like add patient, put patient name, patient date of birth, patient history, and submit button. So it will be, as you said, it will be an interfaces to insert data or select data from the database in this case. We will have a demo session in this. We'll help you about it. I will make a demo session using Java or Python. I will, in the class, I will create a demo later how you can create an interface and included this or connected this to a database.
Okay, sounds good. Thank you.
Sure. As I said, so I didn't make it as a requirement, just in order that it's out of the scope of the course, but in order that to make a real software with a database, it's better to make an interface. So I said that you will have a bonus. So people who are going to make an interface will get a bonus for this. And I will try my best to make a small demo about how to create an interface that talk with a database. People, they have already finished the CIS 245 before. We did this using PHP, but I will do it not using PHP, using another programming language that most of you know about it. I think so most of you people here know about Java and Python maybe. So I will choose one of them where I will make a demo for you how to connect a database using higher level programming language. I highly recommend now that people start working in the project to agree first about the subject. Then you make the design, the whole design steps. Make the AR, the relational schema, build the tables in your MySQL server, because you should finish this now before you start working with the DML part. Okay, let me now share the lecture for today. So today we'll talk about relational algebra. Just let me connect from another place. So relational algebra. This is what we have already discussed the last time. We talked about normalization and as an evaluation process to evaluate our design to be sure that we don't have anomalies or redundancy in the data. And we talk about preferential integrity constraint at the beginning, then we talk about normalization, as I remember, or maybe no, we didn't talk about this. Is what the lecture before. We just talked about normalization the last time. So any question about the last lecture? Okay, good. No question. We can continue with the lecture today. So today we'll talk about what is a relational algebra and we'll talk different operations. And then we talk at the end how we can combine operation to form a queries. And then we will have, like always, a lab exercise by the end of the lecture. So algebra or relational algebra. Before I will start with what is a relational algebra. So the word algebra, I think so most of us familiar with this terminology, algebra. And you had algebra in the high school, and you had this also during, even though you're starting the middle school to high school and also here in the university. So what is algebra? Anyone can give me an answer for this? What is algebra? Alan.
Yes, hello.
Hi. So what is algebra, Alan?
If I try and think back, I think it's math where with like x's, like variables.
Perfect. So we have variables, just variables.
And functions.
Yeah. So we have variables and we have operations like x equal y plus 2. So we have variables and we have different operations like summation, addition. So all they are operation. Is it correct?
Yeah. Sounds right.
So thank you so much. Yes. So an algebra is where we are going to deal with different variables and different operations. And normally the variables at that time we name it operands. So why this has to be included here? Why to include something about algebra and relational algebra with database system? It's weird. Why you have to have this here? The point that before we start with the DML later, which is data manipulate structured query language, before we start with this part about the DML part where we are going to deal with the data, not the structure of the database. So far, we are done with the structure. We know how to build a nice structure, a well-structured one, and we know also how to evaluate the existing structure using normalization. So The point now, how we are going to deal with the data, how we're going to insert data or select data, select from the database, or insert a new data. And sometimes when you are going to select a data, it will not be from one table because we are dealing with a relational. You see now, a relational database and relational algebra, there is something common now. So in the relational database, we are going to deal with the data with a data that's being already related to each other, since the table or the relation, they are related to each other. That's good. Again, what is the relation with the relational algebra? So algebra is operation and operands, as our colleague has already, Alan has already discussed this. However, relational algebra, it's talk more about an operation between relations. So the relation, which is sets, can be as a set. So for us, we have set of relations or group of relations, which is our database. And in reality, also in algebra, there is something which about relation. Like if you remember, I'm quite sure you have this before, like you have a set A, you have element here, and then you have a set B, you have set of elements here, and then you have to make some operation like A intersection B, A union B. So the relational algebra, it doesn't work with variables, it works with relations. So we need to learn relational algebra to have the theoretical foundation, how we can create operations in a specific relation or dealing with different relations. And later, using DML, we will write the SQL code that resemble these operations. So if you are going to learn how we will deal with different relations, so we will apply the same for the tables in the database. But after we will learn about the operation and their name and how they will work and how we can use more than one operation, here's this word, to create an expression. So after this step, we can go and learn how we can create the SQL for this operation. So the relational algebra, it will be a pre-step where we are going to learn the theoretical foundation about dealing with relations and operation between relation or operation in the same relation. And what we are going to do later, just to write the code, the SQL code for this operation. So as we said, so the normal algebra that we know, talk about operators and operands, which is like this here. Here we will have, this is an expression. Here we have a variables. Here we have constants, and we have here the operator. And this is an algebraic expression. In the relational algebra, we will deal with relations or a sets of data, which is in the database is table. And we will have different operations between these relations. We will learn these different operations and these steps. And later, as I said, we will learn the DML code for each operation. So let's start with the operation in this case. What different operation we will have? We can see that we have 4 different so far that we are going to deal with this today. 4 classes of operation. Set operations, like union, intersection, difference. We have operations that talk about a small part in the relation, like selection and production. And we have operation that doesn't talk about within the same relation. It talk about how we can get or combine data from different relations, like joining or Cartesian. And the last time about renaming without changing the tuple in this case. So now, before I start with this, you should be aware that when we talk about selecting a data or in or combining data from different tables, we are not changing the structure. We are getting copy of this data. If we're going to write your program later, you will get a copy from this data, copy from the first table, copy from another table, and make any processing and display the result. So this operation doesn't change the data, except if you are going to execute a query or operation that change the data, like delete, insert. But when we talk about selecting data and taking a part from this data, we are just taking a copy from this data. We are not changing the existing structure in this case. Again, we are getting a copy from this data. We are not changing the existing copy in this case. Okay. So let's talk now about what is union, intersection, and difference in this case, which is the first set of operations that we are going to deal with this. These operations, in order that we apply a union, intersection, or difference, then we should talk about operations that they are from the same schema. We said how it should be the same schema. Normally, we will not apply a union and intersection to the table that existing directly in the database. Maybe sometimes we will make a joining for the data from set of tables, another joining, and their output, we will make a union or intersection for them. So to use union, intersection, and difference, what we name it set operations, the tables or the relations that you are dealing with should have the same schema. Example. So suppose we have two relations, relation R and relation S. In R, this is R, and this is S. Two relations. They have different data, but they have the same schema, the same set of attributes. So how we are going to deal union, intersection, and difference? So the union means that you will get, again, the union mean that you will get you will get a combination of the records from both tables, combination. However, because at this level, we are dealing with the relation as a sets. Later, we will deal with them as a bags, not as a sets. So since we are dealing with them as a sets, so in this case, no duplication is allowed in the output result. So in the first, we have Carrie Fisher and Mark Hamill. We have two records, two tuple here. And the second one, we have Carrie Fisher and Harrison Ford. So another two records in this case. However, if we are going to go to the union, we will take what we have in the first plus what we have in the second without duplication. So Carrie Fisher, so I will take this and this, I put it here. However, for Carrie Fisher, I will not take it again because it already exists. And I will take this Harrison Ford since it doesn't exist. So the union is a combination of the data from both. This R union S, it will be an output. Virtually, I will get it. There is no change in the structure. There is no new table will be there. Later, when I will execute this DML query, it will return this table in this structure. However, there is no table is being already created. It just will return the output in this structure. Just the output will be returned in the structure in this case. When we talk about intersection, R intersection with S, so we will have intersection mean that what you will have in the first, and you will have in the second. We are talking about the data. So what records, you have it in the first, and you will have it in the second at the same time. So we have here Carrie Fisher. And this record. And this is another record. So this is a common, so we take it. In the second, Mark Hamill, we don't have Mark Hamill here, so we will not take it. Here we have Harrison Ford, but we don't have it here, so we don't take it. The output will be only Carrie Fisher record. R minus S, or R different to S, here we are going to take what we have in R and we don't have this in S. We don't have this in S. So Carrie Fisher, we have it in R and we have it in S. So in this case, we are not going to take it. Mark Hamill, we have it in R, but we don't have it in S. So we are going to take it. So Mark Hamill's is the only record that we are going to take it as an output here, because Harrison Ford, we will not take it because it doesn't exist in R and doesn't exist in S. So R minus S, we are going to see what we have in R and we don't have in S. Any questions so far? Okay, no question. I will ask later. Don't worry. So ask now before I will ask. Projection. Projection, it is an operation that we will apply to a specific relation only. And by the way, each operation, it has its own symbol and it is a standard. Later for this operation, we will write the DML code. So here we will have projection. Okay. This is the projection sign, the pi. And here, when we are going to write this operation, we will write the projection as a symbol, and then we will name the table here or the relation. And what is the set of attribute where we are going to select the data related to these attribute only. Example, we have this table, movies. I am asking you to execute an operation, projection, title, year, length. So in this case, the output will be the data related to these attribute only. So the final output will be like this. Again, we are not changing the structure. Still in the database, we have the table movie as it is here. We are not changing the structure. Still in the database movie, we have the table as it is. So we are not changing the structure. Just we are selecting a copy of a special data, and we display the output based on this operation. And this output, we will display it virtually, and then if we stop after this, we close the software. There is no anymore. If I will not save the data, there is no any copy of this data. So it is an output for an operation, and later it will be an output for a query. The projection, normally when we will have more than one operation, listen to this. When we will have more than one operation, the projection will be the last operation that we will do it, where we are going to select the data related to a special a special operation, because, or a special, sorry, related to special attribute. For example, you have a database with table student, and you have student name, last name, first name, last name, date of birth. And I'm telling you that please pick up from the system just the first name of the student. So you are making a projection of the data by selecting a data related to a special attribute in this case. Our first exercise for today. So Brainy is asking, what is the output of the following? Pi, Jenner, movies. What is the output here? Go ahead, Josh.
You just get an output that is the genre column.
So we will have one column, which is a general one. And how many records we will have here?
3, sci-fi, comedy, comedy.
Okay, so we will
Or
have
we only have
3
just the sci-fi and comedy.
comedy. So it is, Kura said that we have 3 like you. I have also more than one. So Simranpreet said we will have science fiction comedy only.
Yeah.
So Ivan say that we will have 3. So Ivan say we will have also comedy. So what will be your final answer in this case?
I assumed it was just the 3, just sci-fi, comedy, comedy.
So we will have a 3. 3 record. Is it correct, Josh?
I hope so.
So I see from the chat that all of you agree on this 3, 3, 3, 3, 3. Unfortunately, this is incorrect. So the
Is it
final
because
result,
we have a duplicate?
yeah, the final result will be
Okay.
without duplication. Again, this is because we are dealing with the relation as a set. If you are going to deal with them as a bag later, next lecture, then the duplication is allowed. But as I said, since we are dealing with them as a set, so no duplication is allowed when we deal with them as a set. So since we are dealing with a set, no duplication is allowed. And then in this case, we will have a science fiction comedy in this case. Selection. Selection is another operation. So where we will have, this is a symbol, like sigma, maybe they name it. And then we will have the name of the relation. And then we have a condition. And we are going to return the whole record of a table based on a condition. Not the whole record, sorry. We'll get the record for the whole attribute, but based on a condition. Example. So we have again the relation movies. And this is the operation selection length greater or equal to 100. So I will double check the records that satisfy this condition. So we have this, we have this. Both of them satisfy this condition. Star Wars Galaxy Quest were length 124 and length 104. So this is, we will not take it because it doesn't satisfy the condition that talk about length greater or equal to 100. So the output will be, will have the whole attributes. However, the records or the tuples that satisfy this condition. So the projection will get the whole record for a special attributes. Here, we will get the whole attribute, but not the whole record, with the records that satisfy a special condition only. So here we will have another condition, two conditions. So we have a Lansing greater or equal 100 and the studio name equal Fox. So we are having a two condition within the same relation. So Lansing greater equal 100 and studio name equal Fox equal movies in this case. So we are going to search for record that satisfy both conditions at the same time because and. So these both satisfy the first one, which is Lansing greater or equal 100. And we have another condition studio equal Fox, which is in this case, this is the only record that will satisfy it. So in this case, with the final output, we will have only this one. So when you deal with selection, you can create more than one condition for the same selection operation. Besides two, Brainy is asking which of the following statements is correct? Which one is correct? Josh, do you have a question before we go to this? Go ahead.
Oh, no, I had an answer for the question. Sorry.
No worry. Okay, I will get your answer. Just I will wait for the other also. So people they don't want to do it to give an answer or participate using your own voice, which is I prefer, but still you can participate in the chat. Go ahead, Josh. Josh, go ahead.
It would just be A, because when you're doing
A.
a selection, you're selecting a group of tuples based on a specific condition. And then for a projection, you're choosing a specific column and only taking the set of that. So that means that we're not going to have any duplicates there. So
So
yeah.
B is incorrect in this case.
Yeah.
Okay, thank you, Josh. Let's see Ayman and Harmandeep. Ayman.
I would also say it's A.
Perfect. Harmandeep.
It's A.
Is it A because Ayman and Josh say A, or it is A?
No, because as we did the example for the projection, we just choose one column, and for
Okay.
the selection, it was tuples. Yeah.
Yeah, that's correct. So, by the way, since I'm giving you as an online course, I give the same course in person. So in person, I will distribute snack for people that will give correct answer. Unfortunately, here it is an online, so I can't share a snack with you. So yes, so it is the first one, the first A, as our colleagues Ayman and Harmandeep and Josh said. Yes. So let's now go to the part where we talk about Cartesian. Or now we will start talking about operation that join data from more than one relation. Joining data from more than one relation in this case. Cartesian. Cartesian is where we are going to. Ayman, do you have a question or are you still raising your hand? Okay. So Cartesian product or cross product or just product of, to say it in more simpler way, whenever we have a two set like R and S, and we are going to we denoted it by R cross S. And let's take an example and we can discuss it more by using an example. So we have here R, this is R, and we have here S. So the final output where we are going to combine the data by using each record on R with the whole record in S. So I will start with this as a first. I will take it with this, with this, with this. Here we say this is a combination with this. This is the second one, and this is the third one. And then I will take the second record with the other, was the record, with the whole record in the second table, was this, here, here, and here. So we will have 3, 4, 2, 5, 6, 3, 4, 4, 7, 8, 3, 4, 9, 10, 11, which is a combination from this with the whole from here. So if I have 2 records in the first and 3 records like here, so the final output will have 2 times 3, 6, because each one in the first relation will be related to the whole records in the second relation. So the final output, or the number of the record in the final output, will be multiplication from the first and the second. And the final number of attribute, it will be summation of both. So if I have 2 attributes in the first, 3 attributes in the second, the final number of attributes will be 5, as we can see in this example. Another example here. Here we will have employee and dependents. So the cost, as we said, we will take this with this, and this with this first. We can see it here. And then we take this with this, sorry. We take this with this, and then this with this. We can see it here. Any questions so far? Another one is about natural join. Natural join, which is more practical to use it, because normally if I want to join data from 2 tables, I will not join everything from here and there. Normally I have to join based on a condition. So natural join say that whenever there should be a condition to use this, whenever you have a common attribute between 2 relations, you can apply natural join for combination by taking the common value in the common attribute. Common value in the common attribute. Again, common value in the common attribute. So, and normally we have many cases where we will have a common attribute. For example, you have 2 tables, they have a relationship, and they have a foreign key. One of them had a foreign key, which is a primary key in the second. So there is a common attribute, which is the foreign key in this case. Here, we will have a common attribute here also B. So if there is a common attribute, now we can go to the operation natural join to apply it. So we will say the first record, we will check if in the common attribute, which is B here, do we have now in this row a common value? We have here 2 and we have here 2. So yes, we can take it. So 1, 2, 5, 6. Now we will take this with this. Do we have a common attribute here? This is 2 and this is 4. So do we have a common value? It is not the same value, so we are not going to take it. We will take now this with this. Here we have a 2 and 9, so we are not going to take it. We will go now to this, 4. We have here 4, so we have here 2, so we are not going to take it. 4 and 4. So here, we have a common value. In both cases, we have 4. So we will take it 3, 4, 7, 8 in this case. We have here 4 and 9. So we are not going to take it because we don't have common value. So this will be the only output in this case. And since we are taking only the common value and the common attribute, so there is no need to make a duplication for the common attribute. We just keep a copy from this, because if you are going to make a duplication to be the same, 2, 4, 2, 4, not like the Cartesian, we will make a copy. Here, we will not make a copy of the common attribute in the final output. Don't forget about the symbol. You should be aware about the symbol for each operation. The size is 3 now. So Brain is asking what will be employee natural join group. What is the output here? Go ahead, Josh.
We're just going to have the entirety of the employee table, and then we're going to take the manager column
okay.
from.
Wait. So just tell me first what will be the structure of the output. So what are the attributes that I will have it in the output?
We're going to have the name, employee ID, group name, and manager.
Okay, so we will have 4 attributes in this case.
Yep.
Which is correct, yeah. And we can apply it
then-
because we have a common attribute, so we can apply it.
Mm-hmm.
Okay.
So it's basically going to be the exact same table as employee for the name, employee ID, and group name. Those will stay the same. So you'll have Jens, Marcos, Shant, and Lucas in name.
You mean that this is, we will take it with this. And then
So
we will
do you
take
mind if I
this with
just
this. No, it's okay. We can do it here. Don't worry. We can solve it here.
Okay,
So
yeah.
we will take this with this.
Yep.
This is the first output, the first tuple. And then
Yep.
we will take this with this. With this will be the second one.
Yep.
And then,
And then
we
the
will
third
take
one would be
this
taking it with
again.
Jens.
So this will be the third one. And then we will take this with this again. This will be a fourth one. Is it correct?
Yeah.
Yeah. Thank you, Josh.
No worries.
Thank you, Samran. You just give us one of the records. That's correct. What about theta join? Theta join is talk more about, we don't have to have a common attribute, so we can apply it even though we don't have a common attribute, even though we don't have. Here, the example, we have a common attribute, but it doesn't mean that we should have the common attribute to apply theta join. We still can apply it without having a common attribute. In order that we can apply this theta join, we just should have a condition. Like here, the condition is A less than D. So A less than D from here. So we will start one by one like always. Start with this and this. A is 1, D 4. So A less than D, we can take it, which is here. Let's start with the same record with the second one. Here we have a D with 5. A less than D. Yes, then we can take it. Let's go with this one. D is 10 here. So A less than D, we can take it. let's now go with the second one. 6. Six, 2, 3, 4. So 6 here is A is 6 and D is equal 4. So is it A less than D? No, A does not less than D. We will not take it because A is greater than D, not less than D. Senior, go ahead.
Sir, in this one, like theta joins, these are numerical values, but what if these are categorical value, like
That's a good
names? So how
question.
we will
So
compare?
in this case, you will build your condition based in your database. For example, we are dealing with textual data, for example, textual data, where you are going to build a condition based on this textual data. In this case, you will build a condition like, I will build a condition if they both attributes start with the same character, or they have a character in common, or start with T character. So the condition will be based on the data itself, how it is. So we will not use numerical condition when we are going to deal with textual or string data. In this case, we will use a string condition. Are you okay, Senior?
Okay, sir.
So
Thank you.
we will go all of this so till we will get this the final result in this case based on this condition. Now we have an exercise as from this theta join. What is the output of this? We now have two conditions, A less than D and U times B, which is B from the U1. This sign means that not equal, not greater, not less, so not equal. So A less than D and B not equal B, so UB not equal VB in this case. How we are going to solve this, or what is the final output will be for this operation? Anyone has this? Josh, go ahead.
I think it would just be one row, which would be 1, 2, 3, 7, 8, 10.
Yes. Yeah, correct. This is the only row that satisfies this condition. So we will have Kahoot one. So do you want to start the Kahoot or take a break and then do the Kahoot, or we'll take the Kahoot now? What do you prefer? So let's make this voting. So do now. Okay, so people who want to do Kahoot before I forgot. I like it, Ivan. Kahoot before he forgot. So if we take a break 10 minutes, he will forget everything. It will be a short Kahoot one, just 5 questions. So, okay, yes, let's do Kahoot then. So let me prepare it. Be aware, you can join using your computer or your phone, whatever it is. So let me do the go to Kahoot one. So this is the game pin. So you can now join all using this pin. Just go to Kahoot and put this pin. I think some more people to join, yeah. All ready? We can start. I will start. The relational query algebra is analytical, procedural, symmetrical, instrumental. Instrumental. So it is a procedural, not structural like the SQL, and this it is a more talk about procedures. So it is a procedural, yes. A plus B, or we make this join and make this operation. It is a procedural one. So let's see the result so far. Wow, Ayman, Jay, I think so. This is Josh, Callum, Zach, Navipoon now. Go to the next one. Let's go to the next one. Which of the following is not a type of relation operation? So far, what we have, not a type, not a type. So selection, select, we have already. Cartesian, we have already discussed. Natural join. Sub update, we didn't discuss it. And so this doesn't exist in the relational algebra. Let's see. Hey, Ayman, where you are? Don't tell me that you didn't do it correct.
Yeah, I
Still,
didn't. It always happens.
don't worry. You still can do it. You still can beat Josh. Don't worry about this. I am one of your fans, so I'm waiting you. So next question. Using select operation, you can select that satisfy certain criteria. So select will work in the tuples. So as we said, based on condition, so you can select the tuples, not attribute. You will get the whole attribute, but you will get specific tuples based on a condition. So has nothing to do with the attribute or operators. It's more about tuples, to select special tuples based on a condition, as we have already. Calum, you have streak of 3 correct answers in a row. That's good, Calum. Zach and Josh, you have here. Navipon also. Keep it up. Next, the fourth one. Select operation is denoted by. It's too easy. Too easy. So select operation is denoted by, yes, this sigma 1. I think so. We just discussed this about select, what is a symbol of select. If anyone have any question, let me know about it. So we have Zach's column, Jack, Navipon, Elijah. That's good. Paramveer is the highest climber. Paramveer, you are doing a good job. Keep it up. The last one. A list of attributes we wish to appear in the result is displayed in select project union or rename. List of attributes. Attributes. Too easy. Man, I expect you all give the correct one. So, yes, it is a project. So we said select, you select special tuples based on a condition with the whole attribute. Project, you will get a special attributes. So it is project. Sure, it is not select, it is not union, because union, normally we do union with the whole scheme, with the same scheme of two different tables. And then we will get it, make a combination of the data for both of them. Project will give you a list of data based on a list of attributes. Do you want to know the result, or we can keep it maybe till the end of the lecture? I think so. We can keep it till the end of the lecture. What do you think?
I think we already know who the winner is.
Maybe we know
so-
the first, but we don't know the second and the third. You want to know the result now?
Yes.
Okay. Elijah. Eamon, you are the fourth, by the way. That's good. And Ivan, the fifth. Okay, guys. So I hope that you already benefit from this. I will give you break 10 minutes and you will back at 9:50. Go ahead and pick up your coffee, refresh. So to complete the second part in the lecture, we will do it at 9:50, okay? See you after 10 minutes. Just Aye.
Bye.
Let me share again my screen. So before we start with our Kahoot quiz, we finished discussing about set operation, projection, selection, Cartesian product, natural join, zeta join, all these operations. Still there's one small operation to discuss it before we will go to the next one, which is combining operation to form queries. So naming and renaming. Again, we are not changing the structure. There is no change for the structure. So when we talk about naming and renaming, we are talking about the data that we are selecting or whatever we are doing, or combining data. This is the data that we are returning as a result. Here we are going to rename the name of the attribute or the name of the relation, or give a name for the output relation. So we are not changing the existing structure in the database. So the renaming can be a renaming for a relation. We give it a new name during the operation that we are doing. And normally renaming or naming, we would use it as a part from another operation. Or we can make for a special set of attributes. So taking, let's see, this example. So here we have a relation R in the database, and we have another relation S. And rather than saying R cross S, I will set R cross S after renaming. So here, rather than having, for example, BCD, I will say, okay, go ahead, take copy of S, however, rename B and give it as X. So the final output will have XTD, will not have BCD, because I told the system, the compiler, that we need to rename the existing attribute. Sorry, as I did here. So I didn't make directly R cross S. I make R cross this, which is the renaming of S by renaming one of the attributes. I kept the name of S as it is, even though I can change it. However, I renamed one of the attributes in this case. So, or sometimes I will do the operation itself, and the output, I will rename it like this here. So the output, I will say, give it a name RS, and the B, give it as X in this case. So it depends. So now, what about combining operations to form queries? And this is a more realistic, because normally we will not use only one operation. Like returning back to algebra, in algebra, you will not only use X plus Y. You will have X plus Y divided by Z plus 2, and then maybe make another multiplication dividing by another numerator and denominator. So you will have different operation to form an expression. And this is what also will happen in relational algebra when we deal with relations. In relational algebra, we are going to deal with different operation at the same time, but with a special sequence. So there is an operation should be done before the second one. As I said, so in algebra, you have a complex operation. And in relational algebra, we can have something we name it expression tree. So suppose you have, again, the table movies that we have already worked with this. This is the schema of movie. This is the schema. And the query that you are asked to do it is, what are the titles and years of movies? We said a query, that is a question. You will ask the database management system this question to return with the result. So we are using the relational algebra at this step. So what are the titles and years of movies made by Fox that are at least 100 minutes long? At least 100 minutes long. So what are the titles and years of movies made by Fox? So we need to have the title and years of the movie. So there is a projection. However, I doesn't need all the movies, not the whole tuples or record, just that are made by Fox, which is studio name equal Fox, and are at least 100 minutes long. So the length is 100 minutes. So if I have to think about this, I said I can think about it like, first I have to select the tuples that have length greater or equal to 100. First. Second, based on the first output, which is the operation of the tuples length, I can make another selection to select from the selected one where studio name equal Fox. If I will not do it as a sequential, so I return it back to the database, which means that get movies length 100 and then get movies studio name equal Fox, and then I have to make intersection to satisfy both of them. And at the end, I have to get title and year. Okay, what I'm saying is, so movies make a selection operation 100, another selection operation equal Fox, and then I will make intersection for this output and this output. From this output and this output, I will make intersection. And then I will say, okay, after this, I have to make a projection from the final output because I don't want to have the whole attribute. So if I want to write it as an expression, and normally the expression, we will read it from internal to the external. So I have here intersection between two selection. And then based on this, I will make another projection. So if I will do it as, there is more than one way to write an expression. Maybe this is not the optimal way. Like when you write a code, there is more than one way to write your code. There are sometimes where you write a code and you see that I can write it in a shorter way, then it will be more efficient. The same here. I think so this is the same expression. We can re-edit it now to have a better one, which is it will be more efficient. What do you think? Can I rewrite this expression to satisfy the same condition, the same projection? Go ahead, Josh.
Well, I would typically say that, hey, you could combine the two selections together, but it's also on your slides, so.
Okay, I don't know. Yeah. So yes, so we can do it in a way that combining the two conditions at a one selection, rather than making selection, and then intersection. I can say, hey, I can make a one selection with two conditions at the same time and then make a projection, because the selection will give me the whole list of attributes with a specific list of tuples. However, the projection will give me a list of attributes that I needed, because I don't need the whole attribute, I need a specific attribute. And keep it in your mind that projection is always the last one to do it in this case. Saying this, I will go to the lab exercise. So like always, I will distribute you in different groups and I will be in different rooms. I will give you, let's say, 15 to 20 minutes to discuss it, to do it, and then we return back to here to discuss the final solution in this case. Let's go to the groups now. Let me stop sharing. Rooms. I have to delete the old rooms and create a new one. Asia, why you are still here? Sinyam, why you are here?
Hello, sir. I got disconnected. So just join again.
Okay.
Hey, my internet disconnected.
Yashvir, where you have been? Which room? You are not assigned in any room. Sinyam?
Hello.
Yeah, Yashvir, you are not assigned in any room. Sinyam?
Sir, I could not see like when you assigned it got disconnected.
Okay, in which room you were? Do you remember?
I guess three. I guess three.
3. Okay. Let me check it for you. So I can see here in CSV. Let me see how I can do it. Sinyam. It's see here in room 1 you are. So in room 1. So room 1. Sinyam, you are in room 1. Ask to join. I will ask you to join again. So now just accept this. Yeah.
Okay.
Mm.
ये तीन ही बंदे
Taj, you were not in an room, I think so.
And then we select only employee name attribute to present as a result.
We are in the main room now. Okay.
Oh, sorry.
Don't worry. I know that you saw that you are still in the same room. Just it take time to close the all rooms that will go sequential.
Yeah, okay.
Okay, I think so all of us are here. So anyone want to share his or her solution or their solution with us? No one
Sure,
want to share?
I can share.
Go ahead.
I just finished it up in here. So there we go. So for the first question, we were asked to find two alternatives to get the employee ID of pilots who are certified on Boeing. So our idea was we wanted to project employee ID for both of these. And then this is where things were a little bit different. So we could either do a selection from the union of these two, or we could do a theta union and give it the same condition as a selection there. For number two, we just did, we were asked to assume the table resulting from a query in question A, which I'm assuming was question 1, is renamed R. State in an English sentence, what does the following expression perform? Where
let's go one by one with this. So
Okay.
the first one talk about, the question was, can you share the question from your side, then we go to the solution? It's better to do it like this.
Yeah, give me a second. I'll just reshare.
Can you hear me, Josh?
Yep. Hello?
Josh,
Can you hear me? Can you hear me?
I have problem with.
I can hear you, Josh.
Sorry.
Okay. just
Can you
confirming.
hear me now?
Okay.
Just I have problem
I
with
can
the
hear
speaker
you.
here.
Yeah, I can hear
can
I
hear
can hear
me?
you, Ismail. Yeah.
Device
Give me a
settings.
second. I'm going to reshare my screen.
I can hear both of you guys,
Not
but
sure
I don't
about what
know
happened
what's
here.
going on.
Unfortunately, I have problem with my.
So maybe he's muted us. Okay, can everybody see that?
Yeah, I can see it.
Yeah,
And
we
I
can.
and
can
I,
see it,
Yes.
I can hear you too. I don't know if the prof can hear any of us.
Yeah, I think he might have muted the entire chat. I don't know, but
Yeah,
I
it
guess we'll
looks-
just go with this and I can explain it as we go. I don't know.
All right.
So
sounds
for
good.
question 1, we're asked to find two alternatives to get employee ID of pilots who are certified on Boeing. So to do that, I did a projection of employee ID with a selection across this union, right? So we know that certified is our certified employees, and it tells us the aircraft ID and the employee ID. So to find out if it's Boeing, we need to get it from aircraft, which has our aircraft name, right? So the idea is that if I do a union on these two, it'll put them together and it'll stitch them together along this aircraft ID.
Just can you hear me now again?
Yep, I can hear you.
Yeah,
I've been able
okay,
to hear you
because-
this whole time.
Yeah, we can hear you. Okay, that's good because I was not hearing you. Maybe the problem with the speaker. Just I have to connect these connects.
Yeah.
All good.
Do you want me to restart?
I'm sorry. So just
all good.
The first one, it find two alternatives to employee ID. So since you have already discussed, yes, let's discuss the solution. Yeah, perfect to do it like this. So the first one is you make a Cartesian product. Okay,
so
let's give a hint how we should think about it. So the first point we should think about which tables or relations we have to deal with. So here I'm searching for employee ID who are certified on Boeing. So they should be certified on Boeing. Boeing is the aircraft name. Is it correct?
Yep.
So the aircraft name will be from the table aircraft. And the employee ID, I have two options, either go to certified or employees. And since the certified and aircraft, they have a common attribute, in this case, it's better to consider aircraft and certified. Just I'm thinking loudly in a way that how I can think which relations I have to need it, because to build a condition based on certified on Boeing, then I need to have aircraft name, which is aircraft table. To get employee ID, I have to deal with two different tables, either with certified or employees. In this case, I'm going to deal with certified because certified has a common attribute with aircraft. So this is the two tables. The first one was certified join aircraft. Yes, that's correct. And then you build a condition which may aircraft name equal Boeing. And then projection will keep it till the end, as we said, because it will be the last operation to deal with it. Or you make a SETA join, which is aircraft Boeing equal Boeing certified. Yeah, or there's still also another option to make a selection in certified and then make a joining with aircraft. Which means that make a natural join aircraft certified, and then I make a selection aircraft name equal Boeing. This is another one. So there are more than one alternative. Josh, go to the second one.
Yeah, the second one's right here. Can you hear me yet, or is it
Yeah, we
still...
can hear you.
Okay, so for the second question, we're asked to assume the table resulting from our query in question A, which is question 1, right? So whatever we got here, so this would be just our temporary IDs, just a list of those that can pilot Boeing aircraft. I guess I just explained it, but
okay.
The idea is that we are renaming this to R, right? So that's our employees that can pilot Boeing aircraft. And we're stating in an English sentence, what does the following expression perform? So here we have the projection of employee name from the union of employees and our relationship R. So what this will do is it'll take this over here and combine it with our whatever we had before, which is our employee IDs.
That's cool.
And what we'll get out of Josh, that is...
Okay, so first, when we're talking about the third one now, is it correct?
I'm just talking about the second one here. I'm just finishing it up.
Okay, go ahead. Sorry.
So what we're going to get out of that is we're just going to get the employee names associated with the employee IDs that we found earlier, right? So these employee IDs refer to the employees that can pilot Boeing aircraft. right? So what we're doing is we're getting a list of names of all employees that can pilot a Boeing aircraft. That's all we're doing. And then for number 3, we're using a Cartesian product or a cross product, and the note number 2, which is this one over here. And we find the aircraft IDs that can fly nonstop from LA to New York. So first thing I'm thinking is, okay, well, how do I find out what the distance from LA to New York is? So I look and I find that flights has a from and to and a distance associated with it. So I can say, hey, from LA to New York, I can find the distance. So that's what I did. I did a selection from LA and to New York. And then I was wondering, okay, well, how do I know if the airplane can fly nonstop from LA to New York? Well, I want a range that is greater or equal to the distance between those two. And we know from note 2 that an aircraft can be used for any flight provided it has sufficient range, right? So we say we want to get the cross product between these two.
So,
and now we
Josh,
can...
how you know that you are going to use these two, not other tables? How you know that you are going to use these two?
So that's what I was about to get at. I'm going to be using a cross product between these two because I know I have my range in here, and that's the only place it's present.
That's what I want
So
to hear.
the idea then...
we have to choose the tables based on the attributes that you are going to build a condition based on this, or the attributes that we are going to make a projection for them, though. If there is an attribute you are going to make a projection, then it should be in the tables that you are joining, or you are going to build a condition based on this attribute, they should be in the tables that you are joining. So in this case, like Josh said, so we are going to use the flight and aircraft because the conditions concerning the range and the distance and the from to exist in these two tables in this case. Continue, Josh, sorry.
Yeah, no worries. So what I'm doing now is I'm comparing my distance and my range, right? So we had our from to, and then I want to add an extra condition, so another and, where the range has to be greater or equal to the distance, right? So using the cross product, now we can find the aircraft ID that can fly us from LA to New York, right? So we just project the aircraft ID that is associated with that, right? Since we've done the cross product, now we can get the aircraft ID from it.
100% correct, yeah. Yeah, I agree with the solution. Thank you so much, Josh, and your team. Anyone has any questions before we leave today? Sorry. More question? Okay, perfect. So, like always, go ahead, Navipon.
Yeah, for the first question, sorry.
Sorry. Yeah.
So for the first question, Josh used Cartesian, right? When join the table, can we use like union or intersection sign instead?
Union intersection cannot be used if they don't have the same schema, but you can use natural join here.
Okay.
Because they have a common attribute, which is employee ID. But if you are going to use union intersection, they should have the same schema, the same attributes, and which is not the case here.
Okay, thank you.
Sure. Navipon, you did very, very well in the midterm. I remember I corrected your exam yesterday.
Oh, really? But we still can't see our grade, right?
You should be able to see it, I think so. Did you check it today?
I just checked when class start, but I cannot see.
Okay, no worry, you'll see it later, but you did a good job. So keep it up.
Nice to hear that. Thank you very much.
Sure. Okay, then I need 5 thumbs up to leave here. I will stay here. Okay, many thumbs up. Many people want to leave. Enjoy the rest of the day and see you next week. If you need anything, just drop me an email. I will do my best to reply so quickly. Take care all.
Thank you. Take care.
Thank you. Bye-bye.
Okay, thank you.
Have a good one.
You too. Bye-bye.